Hello everyone, welcome to E3 STEM Academy. Today we'll be learning the concepts of momentum and collision using some free response questions.
We're going to go ahead and continue with the free response questions from last week. So here is the first free response question for you from momentum. Go ahead and first attempt it. Let's go ahead and read the problem first. A small block of mass m is released from rest at the top of the curved frictionless ramp shown above. The block slides down the ramp and is moving with a speed 3.5 v0 when it collides with a larger block of mass 1.5 m at rest at the bottom of the incline. The larger block moves to the right at a speed of 2 v0 immediately after the collision. Express your answers to the following questions in terms of the given quantities and fundamental constants. So when they're talking about fundamental constants like, acceleration due to gravity g, spring constant k, things of that sort. So they said you can use those fundamental constants and you can use the given quantities. That means you can use m, 1.5 m, 3.5 v0, 2 v0, right? Now, there are small details in this problem that you need to pay attention to. I would recommend that whenever you read the problem, go ahead and highlight or write down that information so that it's easy for you to actually comprehend what the problem is saying. So what I'm going to do here is I'm just going to separate the information of the two objects. So I have a block of mass m and another block of mass 1.5 m. So I'm going to go ahead and write down the information for each of those objects separately. Okay, this is just to make our life easier when we are solving problems. So they told us that the block was released from rest. So the block was initially at rest. So here it's v0 is equal to 0. And when it comes all the way to the bottom, right before it collides with 1.5 m, its velocity is 3.5 v0. Okay, so I'm writing the information right when the collision is occurring, right? So the mass m is colliding with 1.5 m with a velocity of 3.5 v0. And 1.5 m is initially at rest. They already told you. So I'm going to write that down. So here it's initially at rest. Let's label this as v0 for each of them when the collision is taking place, right? Then let's look at the other information. The larger block moves to the right at a speed 2 v0 immediately after collision. So after collision, it's moving to the right. Right is positive. So I know that the final velocity is going to be 2 v0. This is the final velocity that I'm writing. And I do not know what the final velocity is for the mass m. So I'm writing this information down so that it's easier for me to work with. Okay, keep that in mind. Now let's look at what they're asking for. In part A, it says determine the height h of the ramp from which the small block was released. So they want us to find h, this right here. So in part A, I'm asked to find h. How do I find that? What concept am I going to use to find h? I'm going to use conservation of energy to find h because I know that when the block is at the very top of this ramp, it's going to have gravitational potential energy, right? So it's going to have UG. And all that UG is going to get converted to kinetic energy, right? The gravitational potential energy is getting converted to kinetic energy when it comes down the ramp. So if I can equate those two energies for the only reason that it's a frictionless ramp, right? So because it's a frictionless ramp and there is no energy lost, your gravitational potential energy is going to be equal to kinetic energy. So I'm going to write those formulas down. M times G times H is equal to 1/2 mv squared. Now it's the same block, so I'm going to get rid of mass. I don't even need mass. And I want height, so that is going to be equal to 1/2 v squared over g. Now the thing is, what is my v equal to? In this problem, what is v going to be equal to? So v is going to be equal to 3.5 v naught, because when the block M comes down the ramp, its velocity is actually 3.5 v naught right before it collides with that 1.5 m mass, right? So I'm going to plug in 3.5 v naught square of that over g. So now 3.5 squared divided by 2, how much is that? So it's going to be H is equal to 6.125 V naught over G. There's a square on V naught. So it's going to be 6.125 V naught squared over G. That's right. Let's go ahead and take a look at part B. Determine the speed of the small block after the collision. They're asking us to determine the speed of the small block after collision. Now, you have written all the information here. Before collision, the velocity of M is 3.5 v naught. But they want you to find the velocity of M after collision. So basically, they're asking you to find Vf, right, for the mass M. So we're going to use conservation of momentum. It doesn't matter what type of collision it is, conservation of momentum is going to hold good, right, for all types of collisions, which means that the total initial momentum is equal to total final momentum. The initial momentum of block M, so that is going to be M times 3.5 v naught. That is the initial momentum of block M, right? And the second block of 1.5 m is at rest. So obviously the initial momentum of that block is going to be equal to 0. Is equal to the total momentum of the blocks after collision. So it's going to be m times, I do not know what the final velocity of this mass is, so I'm going to leave it as Vf, plus 1.5 m times the final velocity of 1.5 m is 2 v naught, right? Because that's what you see here. The final velocity of the 1.5 m block is 2 v naught. So I'm going to go ahead and plug that in. So it's going to be 2 v naught. So now all that you need to do is simplify it, right? So this becomes m times 3.5 v naught is equal to mvf plus 3m v naught. 1.5 times 2 is 3m v naught. Now I can get rid of m, or in other words, I'm going to divide by m throughout my equation. So m is gone. And so I'm left with 3.5 v naught minus 3 v naught is equal to Vf. I moved 3 v naught to the other side. So it's going to become negative 3 v naught is equal to Vf. So Vf is equal to 0.5 V0, or in other words, it's 1/2 V0. This is the velocity of the block M after collision. Let's go ahead and take a look at C. The larger block slides a distance d before coming to rest. Determine the value of the coefficient of kinetic friction mu between the larger block and the surface on which it slides. So they're basically telling you that when this small block M comes and collides with the larger block of mass 1.5 m, this larger block moved a distance d and came to a stop, right? So it came to a stop. That means its velocity is 0. Its final velocity is 0. Now, the problem says that when the block M comes and strikes or collides with the 1.5 m block, the 1.5 m block moved with a velocity of 2 v0. So the initial velocity of this block is 2 v0 when it starts sliding, right? So it started sliding with a velocity of 2 v0 and then came to a stop after traveling a distance d. Now they're asking us to find mu, the coefficient of kinetic friction. Now, if you all remember, coefficient of kinetic friction is the ratio of the frictional force to normal force. And because sigma Fy is equal to 0, I know for a fact that Fn is equal to Fg, which is equal to mass times gravity. So I know Fn, but how are we going to find frictional force? How are we going to determine frictional force? Now, sigma Fx is equal to Fnet because those are the only forces that are accelerating this block. And if you look at sigma Fx, the forces acting in the horizontal directions. So if you are looking at x, sigma Fx, we know that there is only one force, and that force is the frictional force. So Fnet is equal to the frictional force. And that's equal to m times a, mass times acceleration. I know the mass. If I can figure out acceleration, then I would be able to figure out friction. So let's go ahead and find acceleration, because we know that the initial velocity of this 1.5 m block is 2 v0. I know that the final velocity is equal to 0 because it's coming to a stop. I know that the distance it traveled is d. So using kinematic equations, I can find a, the acceleration, right? So I need to determine a. So if you all remember the kinematic equation, Vf squared minus V0 squared equals 2 times a times delta x. You can find this equation on your formula chart, on your AP formula chart. So I can rearrange this equation to figure out a. So I'm going to divide by 2 times delta x, because I want a, I can divide by 2 times delta x on both sides. So a would be equal to Vf squared minus V0 squared. I know Vf squared is going to be 0. So 0 minus V0 squared. V0 is 2V0. So 2V0 square of that divided by 2 times d, because delta x, the block traveled a distance of d. So now we can simplify this further, and this is going to be negative 4V0 squared divided by 2d. And if we reduce this, this is going to be negative 2V0 squared over d. Acceleration is negative because the force that is causing the acceleration is a negative force, friction, right? It's acting in the opposite direction. So obviously the object is slowing down, and therefore the acceleration is negative. Now I want to determine mu. And mu is frictional force over normal force. And frictional force is mass times acceleration, right? Mass times acceleration over m times g. Now it's the same mass, so I can simply get rid of mass. And so it is going to be A over G. I'm going to plug in the magnitude of my acceleration. So that is going to be 2v0 squared divided by d over g. And so this comes out to be 2v0 squared over g times d. So this is the coefficient of kinetic friction. The coefficient of kinetic friction is 2v0 squared over g times d. I hope that is clear to you. So let's take a look at it. Since it says indicate whether the collision between the two blocks is elastic or inelastic, right? Yeah, so it is the only way you're going to justify when they ask you what type of collision is this, is it elastic or inelastic? The only way you can justify is actually by calculating kinetic energy. You cannot, I would never suggest that you write paragraphs explaining as to why this is an elastic collision or this is not an elastic collision. The only way you would justify smartly would be by determining the kinetic energy of each of those objects before and after, right? If you can show that K initial is equal to K final, then that is going to be an elastic collision. And if you show that the total kinetic energy before collision is not equal to total kinetic energy after collision, then I can justify very clearly using this that this is actually an inelastic collision. So the only way you can answer D is by actually determining K initial and K final. Okay, there is no other way to justify this. And if you try justifying any other way, you might not be able to get full score on it. Okay, so I'm going to take a look at the two blocks that are actually taking part in the collision. And we know that the initial velocity of the initial velocity of block M is 3.5 V0. So I'm going to find the initial kinetic energy first, which is going to be the sum of the initial kinetic energies of the two blocks. So it's going to be 1/2 m V0 squared. So that is going to be 3.5 V0 square of that. And the second block is actually at rest. Before collision, it was at rest. So that means it has no kinetic energy. So the initial kinetic energy of the second block is 0. So K0 would be equal to, I'm going to square this. So that's going to be 3.5 squared divided by 2. How much is that? Can you give? 6.125 m V0 squared is the initial kinetic energies of the two blocks before collision, right? Now let's go ahead and find Kf, the final kinetic energy of the two blocks after collision. So it's going to be 1/2 m. What was the final velocity of the block M after collision? It was 0.5 V0. So 0.5 V0 squared, because that's what we found in part B. Part B, we found that the velocity of the smaller block after collision was 1.5 V0. So square of that. Plus, I'm going to add the kinetic energy of the larger block. So that is going to be 1/2. The mass of that block is 1.5 m. And the velocity with which it moved is 2 V0 after collision. So 2 V0 squared. So now Kf is going to be equal to, how much is 0.5 squared divided by 2? 0.125 m v naught squared plus, this is 4, 2 squared is 4, 4 times 1.5 divided by 2. So that is going to be equal to 3 m v naught squared. Right? So if you add these, that would be 3.125 m v naught squared. So notice what happened here when you solved. I got the initial kinetic energy of the two blocks together as 6.125 m v naught squared and the final kinetic energy as 3.125 m v naught squared. So the blocks have actually lost the kinetic energy after collisions. It has reduced. And because some energy is lost, this is for sure an inelastic collision.